Okay, so good afternoon guys. Madunggan naman ko ba? Guys,
Yes, sir.
madunggan ako. Okay, so welcome again to our second online class. Wala ko nakaklase atong 1 p.m. no sa MR na section. Hopefully na ay naka-join ko. Lagi ni join taga MR kay 41 na mga kabuok. But anyway, it's already available ning basic industrial robot operations ato ang YouTube channel. Just visit our YouTube channel. Okay, so basic industrial robot operation. So kinsa na may naka-laboratory sa inyo? Have you tried industrial robot arm na operation? Kinsa na may naka-try? Na-try na mo tanan? Hello?
Sa computer, sir.
Oo, kata sa computer, nakatry na
Yes,
mo.
sir. Katong basic, sir. Ito
Yes,
first lab,
Okay,
sir.
so kato siya sa laboratory ito. So kani this time, it's all about the lecture. So we're going to discuss the industrial robot operation, not the laboratory no activity. And discuss na to ang industrial robot operation. Okay, so mauna niya sa said, ikan niya siya sa amatrol. Ito nakagamit sa unang amatrol. So, matingala mo na ngay amatrol diya. So, that's the reason that these are sources. Okay, so robot definition. So, may robot diya. So specifically, an industrial robot. So, industrial robot at ang concern as of this moment. So it is an automatic, automatically controlled, reprogrammable, multi-purpose, na manipulator. Na manipulate nimo. That is programmable in 3 or more axes. Sa laboratory na to, kinsay nakadumdum pila ka access ang ato ang gimanipulate or na-manipulate ninyo? Pila?
Target.
Tulo, sir.
Targets to, pero ang access, nakadumdum mo sa access?
Tulo ka
Ay,
book,
tulo,
sir.
sir. Tulo, sir.
Dili to tulo. Kinsay nakadumdum, dili to tulo. It's more than 3.
Axis.
So, kung nakadumdum mo, it's actually 6 katong number of joint axis. So, may pasabot aning axis katong joints niya. Diba? Uno man to ka joint angles, theta 1, theta 2, theta 3, theta 4, theta 5, theta 6. So kato example, 6 axis to. So kaniyang ginaingon nato, it's 3 or more. Okay? So robots are thought of many people as being very human-like because they are often portrayed in the way in the movies. No? So kana advanced na kaya siya ng mga robots. Atong istoryahan karon, kuan ganing gitawag naton industrial na robot. So some are using kaning there are certain types of robot that can move around in the room, such as kanang robot vacuum cleaner, kanang mga na simple lang, no? And some are using artificial intelligence to teach themselves. So that's advanced na. Okay, so let's focus on this industrial machine. So there are 3 features needed to define the machine as a robot. So malagi itong gibaliking on, must be automated, reprogrammable, and able to multitask. So katong video na to the last time, kadumdum mo, katong sa cookies, similar ani na conveyor, a robot can operate without the constant control of a human. Okay? So for a very automated na manufacturing plant, so sad to know na gamay na lang ang mga human interventions na present dira. No? Because of this innovation or the use of robot, industrial robot. Dayon, a robot also can be reprogrammed to perform a task in different ways, such as this CNC machine. So, kaila mo what is a CNC machine? Kinsa na may human sa machining ani dire. Mana na mag-machining? Late machine. Sa na klase na type ng mga machine.
Yes, sir.
Wala.
Mana, sir.
Oh, mana. So, instead na tao may butang, no, gabutang or ga input sa katong object to be kuano, to be processed in a CNC na machine. So, unlike a lathe machine, no, dili siya CNC or kuan siya kanang manual, no? Manual ang pag-shape sa imong object, no? Particularly wood ba siya or metal. But in this case, if a robot is the one that is using the CNC machine, so siya may tag-input kung kinakuha niya ang metal stock, piece of metal stock dito sa sulod, at the same time siya pagkutang after mahuman. So, ano yung example na application wherein industrial robot or robot arm can be used, no, to automate the process in CNC machining. So, mura ginani na example. Okay? So, pag mahuman na o kuan, load, iyan na po i-unload na po niya. So on and so forth. Okay? So we go now to robot applications. No? So robots are used in many different applications such as assembly, symbol siya. Ayun, just like atong sa tatanawan na to sa YouTube sa RoboDecay, kadumdum mo atong simulation sa Game Boy, no? Later ako tong i-save ang file sa ang katong mismong RoboDecay na file sa ang laboratory para ma-open po ninyo, no? So yang symbol ang Game Boy. Okay, so that is for the assembly. Dayon, another application is material handling. Okay? So especially kung paspas ang ginahandle ng material, no? No, para atong cookies, no, paspas kayo to, so nag-packaging siya ato, so paspas kayo. So kung human ang imong ibutang ato, dali ra kay pamaulan, no, papuli na po. Dayon, another thing is welding. So kung familiar mo sa kanang mga cars, no, fabrication or manufacturing of cars, so mutanaw mo YouTube ana, although wala pa ko naka-add to manufacturing sa cars, but based sa YouTube na makita, no, so inana ka ang level na sa welding na capable ang robot, no, even in the production of cars. Machine loading, especially kung bugat siya sa siguro kaning sa sa Pepsi, no, na sila ikuan dito sa ilang ginatawag na packaging nila na stage, no, gina-package nila ang gatong kuan na murag pallet of, let's say, mismo kaya na pwede na ilang murag i-package nila, no, packaging kay para sealed siya, no. So pagkatong nakaadto sa cook na inana na na sila robot, nakalimot na ko sa kalimot ko sa brand sa robot nilang gigamit, as well as painting and glowing and so on and so forth. So dagan limitless ang possibilities, no, sa application sa robots, especially in especially the industrial robots. Okay, nanangutana. Sinangutana si Jimenez. Yes, Christine Joy Jimenez. Okay, pangutana. 76. Okay. So, nangutana lain. Ano tinag-raise sa hands? Ay, nag-log. Okay, so maklaro pa ko? Or nag-log ko?
Okay na, sir. Okay na, sir.
Okay ra. Okay, so let's continue. But anyway, you can always review sa Katong YouTube na channel. Okay, so the next is describe the 3 advantages of robots. So robots have a number of advantages over manual labor, no? Performing many tasks. One of which is improved quality of life. And another thing is improved product quality. Then next is reduce production cost. So when you say improve quality of life, so may kasabutan eh. Since na may mga environment na hazardous, no? Robots can work in dangerous or dirty environments where people should not be working. So pwede na magpulihan ng robot, especially kung repetitive ang task. No? Dayan murag it would be boring for human workers na buhaton. So pwede na siya. Okay? So that's one of the advantage na improved quality of life. In fact, ang ganang bitawang sa kuha, no, familiar mo sa kanang sa bomb, no, bomb squad, sa tawag na sa military or sa police, kagamit na sila remote control na mga kuan wheeled robot with kanang arm gyapon, nagyap siya mobile robot na naay robot arm para ilaharang paano i-check nila kung naaba dito ang bomb, if ever na ang bomb, they're trying to palayo nila ang location. So that is an explanation, example of improving quality of life with the use of robot. Then another thing is improve product quality. So this has something to do with production. No, since in terms of kaning repeatability, no, especially kaning mga industrial robot, taas-taas ni sila o itawag na repeatability. No, kung ang let us say the task kanin sa makita nato is mag-paint lang siya, mag-paint siya, it can be done accurately with with high repeatability na gid na pareha ra gid ang iyang ginabuhat over and over again with the same higher quality. Kung ang tao pa'y mag-perform na, it's possible na part na kung spray lang, spray painting sa part na gamay ra ang part sa paint na distribute wala kay siya na even distributedly ang kaning painting. So that is just one example and so on and so forth. Nagantay possible na let's say kaning mag-building, sometimes kung human factor ng building, di ba, kung makakita mo himbis bitaw para sa himbis sa fish, sa isda ang quality sa pag-weld, kung tao na sometimes di na niya mabalik, no? Gikapoy na siya. Pero kung robot ay may pag-weld, even 24 hours as long that the robot was designed na even 24/7 siguro kayahon sa robot na the same quality na repeat over and over again. Then reduce production cost, since dili man ni mag-sick leave ning robot, dili pud mag-maternity leave. So that is just an example. Then mas taas ang iyang gitawag na quality sa iyang production. Ayan, o pa din can continuously operate 24 hours, no? Dayon, if you're going to compare that with a single robot versus 3 people, di ba? Kaya naman tayo gitawag na kung 3 day na shift or 3 mura ginana, no? Schedule nimo is 24 hours ang operation, so nakagitawag na 3 schedules na shifting, no? Posible magsugod ka 6 a.m. to 2 p.m. 6 a.m. to 2 p.m. So that is 8 hours. 6 to 2. And sunod, 2 to 10. 10 p.m. to 10 p.m. gabi na. Then kato din graveyard. 10 to 6. So mura ginana na shifting. And so on and so forth. Pwede na example. Okay, so whereas kung isa ra ka robot, mag-invest ka sa robot rather than mag-invest ka sa tao. So isa lang ni siya sa mga gitawag na disadvantage na kung highly automated ang atoang kuan, ang atoang plant, so less lagi ang human intervention. So ang katong mga kuan, it's possible na lain ang ilang assignment, dili na sa kaning kaning boring na pick and place lang siguro na trabaho or sa ba packaging and so on and so forth. So mas dili na to gina-consider na murag threat siya, but rather there's room for improvement. No? Improve na ang imong trabaho, dili na katong boring na trabaho na that can be performed over and over again by a robot. So mas kuan siya. That requires critical thinking baka perhaps it's more of quality control, itaas-taas magkaya na ang parameters pag quality control, di siguro na makaya og machine vision lang na ordinary. So pwede na no? So dito ka mabilang na sa quality control instead of pick and place lang or sorting na process sa production. Okay? So na may pangutana. So next is describe the 4 types of robot classifications. So there are many different types of robots with 4 primary ways to classify them. So naobserbahan ninyo pag kaning robotic arm by default it is either stationary or mobile. So katong mobile siguro advanced na to yung application. Then another criteria or category is the number of axes. Okay? So sa katong try nato sa laboratory, it's more of 6 axes. Pwede po ito mo i-change. No? Download ka gato lang 5 axes, download ka gatong 4 axes lang. So depende sa robot na mo ang i-download or gamiton. Then the type of motion. Then the last one is the type of mechanism, no? Or kaning actuator na gigamit. It can be either using a servo motor or a non-servo. So pwede ba siya linear actuation using cylinder, pneumatic cylinder, or using linear DC actuators, so pwede na may pasabot sa non-servo or pwede po hydraulics and so on and so forth. So this sabi niya siya. So a stationary robot is attached to a fixed surface such as the floor, wall, or ceiling. So importante niya siya na attachment dapat it should be rigid, no? Sa ito ang mechanics pa na rigid bodies. Pili pwede na i-attach na itong robot na dili siya rigid. So dapat it should be attached fixed floor, fixed surface. Ayun. So mga namin mga mention ganyan, the typical applications of stationary na robots. Common lang such as welding, painting, assembly, pick and place, packaging, palletizing, product inspection. Pero simple lang siguro, no? Depende sa machine vision niya na capability and testing and so on. However, if it is mobile, kinsa may try aning mobile, kinsa may nakakita aning mobile sa YouTube or sa balita. Ano mo ani? Ako nakita ani sa YouTube kay katong sa Amazon. Though nakalimot ko attach yung YouTube. Pero kung makaadto mo sa YouTube, you can search sa Amazon, no? How they use mobile robots for gitawag nila na how to manage warehouse or warehousing na activities. Na let's say or gitawag nila logistics na activities. At least dili na tao ang mag-sort, mag-distribute, for delivery ba siya, automatic na. So mas advanced na siya approach. Kinigitawag na inani na type example na mobile robots rather than stationaries. So katong stationaries, masayon-sayon po siya. Kining mobile, it's a little bit no? It's a little bit complicated na. Okay. So wala mo kakita atong sa Amazon? Wala mo ka try or even sa kaning Amazon magyapon tong buwan. Itong naglupad mga drones, may pangatod. Amazon dito, Amazon siguro. Or gina-deliver ang products.
Excuse
using
me, sir.
drones. Mm.
Katong sa
Yes.
kwan, sir, katong sa Jollibee, bitaw sa Manila, sir.
Oh, very good, very good. Oh. Yeah. Katong, I don't know kung nakikita pa na ka ng YouTube. Katong sa Alibaba, napinana no sa wait, mura siya waiter ang iyang before ang Jollibee nagpagawa sa nana, siguro pila na to ka years. Siguro 10 years ago, naana ang Alibaba na sa restaurant nila. Yeah, no? So murag kabalo man ta sa technology karon, China man gyud, no? So si Jollibee siguro naka-purchase of one similar na kuan na murag waiter no iyang function, no? Yeah, that's a good example. No? Mobile robot. Or kana pong naman po yung nag-project diri or nag-kuan thesis katong kuano COVID-19 na mobile robot. Naapod to diri. So siguro kung natay time siguro yung mag-project ato no ilang improve. Anyway. So let's continue. So in terms of number of axis, so sa giingon ko pa kanayang mga joints, no? May mga joints niya diri yo. Sa mitong kuan. So importante ng number of axis, no? Pila siya ka joints? 1, 2, 3. So gamay rin yung number of joints. So a robot axis is a linear or rotary direction in which the robot arm can move. So, the more axes, no, allow a robot more freedom of movement. So na sila ay standard no sa ISO. No, by ISO definition, industrial robot must have at least 3 ka axes or more, no? At least 3. So that's why katong example natin the last time 6 siya. Okay? Then in terms of type of motion, so katong sa stations nato dito na handling stations dito, more similar ani no. Similar dili lang gid pareha. So an example is a straight line or linear na type of motion. So mo na siya ang literal na siguro XYZ na movement, no. Dili siya spherical na coordinates na murag ang rotation is rotational. Okay, so example na morning linear, then kaning isa morning rotational or also known as articulated. No, articulated siya. Okay, dagan siya o kana freedom na move. So it's more articulated. Okay? Okay, so example katong servo and non-servo. So kung familiar mo sa servo motor, kitsa na may nakabungkag og microservo dire. Kabungkag din og microservo. Kung bungkagon na nimong servo motor kanang microservo, na siya potentiometer dia sa sulod, no? Katong potentiometer ang role niya to is mag-translate of voltage or resistance, no? Resistance into voltage into angle, no? 0 to sometimes commonly ang servo motor is 0 to 180 degrees. Napoy 0 to 270 degrees. Napoy katong 360 gid na maka full gid na tuyok. Okay? Pero by default mga 0 to 270 or 180. So the difference between a servo from a typical DC or AC servo or DC na motor, AC motor, ang servo na siya feedback. Ano yung example there is ato ang diagram, it's a closed loop na system. Sa closed loop system, na siya feedback na makadetermine siya sa position, sa actual position sa rotation sa imong DC ba na siya or AC na servo. Now in most of the industrial application ang ginagamit is AC servo. No, AC ang servo ginagamit because in terms of efficiency and practicality, kaya ang supply lagi po is either for 40 volts 3-phase or to 20 volts 3-phase. So ina naman, no? Mas practical siya rather than DC. Now there are also using a DC na servo, no? Such as kung nabisitahan sa una dad ko na DC servo is ganang mga steel plants, kanang gahimo og mga steel, no, mga steel core. So naiuban nagagamit og kuan kanang DC na servo, depende ra mo gana sa kuan pod sa design sa kuan sa ganing actuator, no? Okay, so muna to yung basic kalainan. We say servo, it is a closed loop system. Pwede nimo ma-determine yung actual position. Whereas if it is a non-servo, so kung typical lang na motor lang, so example is a stepper motor, no? Though na siya step angle, pero once na mulapas na siya og yung certain degree na step angle, dili na nimo mabalaan kung accurate pa ba to siya or dili exact pa yung position, dili niya makorek unless na siya ay encoder. That's a different case. A stepper motor with a DC encoder or an encoder. Murag step encoder. Bali ma-determine gyapon niya kung sa iyang actual na angle. Now, other non-servo is one. Kani inani na sa gingon ko pa, it's using siguro pneumatic cylinder, linear lang ang iyang actuation or hydraulic ba. So, man examples sa mga non-servo robots. Okay, so na may pangutana regarding what's the difference between a servo and non-servo robots. So kasagaran sa mga articulated na mga robots, kuan gina siya, it's using a servo. Kay importante man ang accuracy sa position. Whereas kaning mga example kaning inani, kuan na siya, full extend, full retract, if ever na butangan mo siya o ganing sensors in between, pwede man po, but not as accurate as the servo na mechanism. Okay? So na may pangutana? Pamilyar man mo aning mga electropneumatics or electrohydraulics. Okay? So kung naan, let's proceed. So we're going to proceed to the 5 basic robot components. So there are 5 main components of a robot. The first one is the manipulator, then followed by the end effector, controller, drives, of course, the programming device. Okay, tanaw na ito kung naabay. Okay, so chay pasabot aning manipulator. So since the robot is doing manipulation, so kaning pagliyok niya, no? Kaning arm mismo, no? Mo ning gitawag na manipulator, kining pagliyok niya. So mo ni ang manipulator, ang arm itself. Pag mingon kag end effector, kung asa po ito imong gitawag na TCP, na katong point niya sa tool ni mong gibutang, no? Tool center point. So dito po, no, manang mga end effector din, example is a gripper. So, okay? Gripper. So pwede po ang end effector nimo is a spray, no? A spray kuan. Pwede po katong sa welding, no, mga pwede mo kuhan. Pwede po drill ang imong end effector, and so on and so forth. Okay? So kani ang example niya is gripper, para sa mag-grip sa ganung object na iyang i-click, then i-place. Then of course the controller, wala na ko na appeal ang picture sa actual ng controller dito. Naara dito sa center, no, sa ilalom. Mismo itong kakita sa Fisto Mitsubishi na kuan articulated robot arm na dito sa ubos. Nakita mo box dito, mga na ang controller that coordinates a robot's movements. So kung sa analogy pa ni sa to ang PC, na to ang system unit or ang kung asa CPU available. Then the drives is na siya dito sulod gyapon sa imong controller. Na siya yung mga transistorized na cards that drives your servo motor. So mga siya mga cards. Kung madaot ang card, pulihan lang. Okay? So kung i-analogy natin sa PC, mura na siya katong mga expansion cards na such as or kaning sa graphics card, marina na. So inana ang mga way back katong nag-troubleshoot mi sa Epson Ascara and I was still working in Butuan. Makita na ko ang card mismo kay ma-open man na mo ang katong mismong ang iyang controller. Pero diya sa taas wala pa na open kay wala pa man po naguba. So doon na siya issue sa battery. Manang wala pa ko kakita sa sulod sa mga drives niya o mga cards for the driving the servo itself. Then this is the programming device. So makakita katong sigla labay dito sa tunga. Kita niyo ni naara ni dito sa ilalom underneath the robot arm. So kung ano yan to ang gitawag na programming device. So derita mag load sa program. Or pwede po kung successful ta, though this will be my first time to use RoboDK, to try. Pwede man ma-connect ang computer with the RoboDK towards the Ethernet na connection sa ang Mitsubishi na articulated arm. Though wala pa na ako na-try kay na battery issue na requirement na i-address na to later. Okay? Okay, so na may pangutana. So na may oras. Wala kami siguro nag-time ba?
Alright, guys. I hope
Okay, so let's continue. So, what are the 8 rules of robot safety? So, sabi na siya. So, kaning industrial na robot, mga motors na or servo motors na na-attach niya is dili low power. So, it's high enough na strong ang ma-generate na torque. No? So, especially if the speed na maset is kusog-kusog po. So, kung masagpaan ka na robot, delikado po. So, that's why there is these safety rules to follow. So, number 1 is remove all obstructions from the robot work area. Okay? Okay, mag-move man siya. So, dapat as much as possible, let us clear before to magamit clear na to ang area for any obstruction. Then number 2 is check for signs or damage to the robot. Kay basig buot-buot padagan niya na sumbag na niya ang gatong obstruction. It's possible that there is damage to the servo or the robot itself. Okay, so you check it before gamiton. And number 3 is remove loose fittings, clothings, ties, scarves, sleeves, etc. That's why when I was working sa una, in a manufacturing plant, kanang bitong na-sling sa ID. No? Di na siya pwede ba eh. Wala dili pag nakasulod sa kanang highly kayo, electromechanical na plant sa sulod. Bawal ginang na-sling na ID. Mato ang mga ID dati is kuan lang, clip lang, no? Clip. Kaya kung sling na siya na nakabutang na sa imong head, sa imong neck, dayon what will happen na nalimtan nimo by accident, mabira siya. So it will be dangerous. Lisod na putlo ng string. Hindi na nimo maputol by your head alone. So kinahanglan kay sharp pa, gunting. Loose fitting. So pasabot, imo ang clothes, kuan na kayo, kanang loose na kayo na magbitay-bitay. So, what if ang imong robot is nagkuan, no? Nag-move siya, then nasangit ang imong mga kuan, parts sa imong kuan sa imong clothes. So maapil kag kabira, ha? Maapil kag kabila. Yeah. As well as and so on and so forth. So importante ni siya. Dapat dili kay loose ang ato ang walay mga something na pwede na mahatak niya na mag-move siya. Dayon, number 4, itong mga tagas daw buhok dapat daw higta na yung buhok. Basin na, masangit po din sa buhok. Asin lang. Number 5 is remove the teach pendant from the robot work area. So kaning gitawag na to na programming device, this is also the teach pendant. Okay, basic maigo siya. So malagpot. And always determine dapat kabalo ka asa nakalocate ang emergency stop button. So kaniyang teach pendant naman stop button. Okay. Dayon, ensure safety glasses are worn by the people in the area. So, from time to time, mag-require to gani safety glasses. Spectacle sa mata. No? Ibasig, malambahan na nagkalit, may guwang mata na ma-damage na. Whereas kung kay safety na goggles, at least maprotektahan imong mata. Okay, then number 8, ensure that all people are outside the robot work area. Okay, so na may pangutana. Okay, so let's continue. So describe the operation of the 5 types of robot safety devices. So what are those? Emergency stops, barricades, light curtains, safety mats, signs, and tape. So dito sa taas, murag emergency stop na nasa tuwa, no? Wala ta nakakita ang barricade sa ato ang robot. Wala pa tayong light curtains dito, safety mats, wala po. So at least familiar taan no. Aning 5 ka types of safety devices for our industrial robot. So kabalo man ta na emergency stop pod ang yung programming device. So mana dapat kabalo ka. Then barricades. So pwede pod butang barricades. So nakadumdum mo atong video na ito bitong i-program niyang absence kara naka-barricade to. No? Pero dili na ni kadako na barricade. Gamay ra kay working environment. So mo pod to. So pwede pa din na ni physical barriers. Then katong mas high-tech gamay kani gitawag na kuano light curtains na nasa sensor. Pag tabok ka ng sensor, makat nimo ang light, then automatic emergency stop nimo ang robot. So pwede na ni. So mas advanced ni siya gamay na type na safety device. Then another thing is kaning safety mat. So lain po siya ni style. Pag once na pressure is applied to the mat, palong po na imo ang robot. Mura siya mag-emergency stop. Okay? Dayon, pwede po signs and tape. So ang uban, tape na lang. Pakabitang na sila yung mga tawagan nila tape, safety tape na butangan nila ng do not cross here, magkita na. No? Okay, na ay forklift ba, galabay-labay, ganyan na. Those are the what signages na ginagamit. So kani it's a combination of the two. Warning signs as well. Warning signs. So kani gi-appealan to the arcades. Okay, so let's proceed. Describe the functions of 4 components of a servo robot axis. Okay, so there are 4 components of a robot axis. Mainly the servo motor. So dili nimo makita physically ang servo motor kay naka-enclosed din siya. Okay? The encoder, so katong ano, ang position ng electronic na system that will return the position signal, the position of the TCP or the kaning ano mo, yung end effector position na niya. Dayon, the mechanical structure, okay? And the home position sensor. So, nakikitawag na home position sensor. Okay, pag once na i-home mo siya, so mabalik siya sa ang gitawag ng home position. So, yung mga home position na sensors. So, servo motor. Itong nakakita na dagko-dagko na servo motor, kining sa likod niya, no? Napod ang iyang encoder dere at the same time. Manang kanira ang ordinary na DC geared motor, ganyan siya nakasaksak sa iyang likod na encoder. Okay? Okay, so manang gingon encoder. Dayon, the mechanical structure, no? So, uban siguro it's possible na for dili articulated na arm katong mga other non-servo na mga motors, it's possible na nasa or even pwede gyapon na ang imong articulated na arm may mga mechanical structures, marag extension sa iyang mechanism. So it's possible na may mga mechanical structures such as gears, chains, bearings, and so on and so forth. Unless i-open mo ang kano na maragin na no? So, nakikitawag na home position sensors. Importante na if ever na ang imong servo dili nakabalik siyang home, so it's possible that the home position sensors i-reset siya or especially pag ang issue sa battery gina-reset ang iyang home position. Okay, so next is describe the functions of the homing procedure. Saan daw pag pabalik naman siya ang default or home position. So these are the terms, no? Kung namina ko sa YouTube ato the last time sa to ang RoboDK. The RoboDK is just katulang simulation ng ato makita pa. Wala pa man nato siya na-connect sa robot din. Nato siya ikuha nito, no? Home. Click to nimong home, automatic siya. So may pasabot sa home. Homing or nesting is an automatic procedure that causes the robot's access to move to a position where they actuate their home sensor. The controller then resets its memory for each encoder position to 0. This makes sure that the robot will accurately go to each position stored in the memory. Okay? So, ang movement sa tong robot is relative to its home position. Okay? So, nakikitawag na kung sa geometry pa, natay gitawag na origin. So, sa to ang axis, di ba? Cartesian na to na axis. So, natay origin na 0, 0, 0. XYZ. So, mga tayo ang home position supposedly. No? If you're going to make an analogy sa to ang program. So homing at startup. The robot should always be home when first turned or before it is operated or programmed. So gingon ko pa relative man sila tanan. Ang next ang iyang coordinate na system is relative sa iyang home position. So dapat naka-home siya pero ano ay pasabot homing at startup. Okay? Let's proceed. The homing procedure for a server robot homes each access in a specific sequence that ensures the robot will not crash into anything. Once the robot moves an access until it has activated its home sensor, the robot stops moving that access and proceeds to the next access in the homing procedure sequence. The time a homing procedure takes varies within the distance each access is away from its home position sensor. Okay, so for every access, na siya ay homing sensor or home sensor. Okay, so may pasabatan niya statement. Okay, so this is just a review na. But anyway, pila man ni siya ka degrees of freedom. How many degrees of freedom does this robot have? Be, katong naminaw, be. Pila man ni ka degrees of freedom. Ang gani ato ang articulated robot. Kung naminaw pa ba? So currently 58 takabo. Pila man guys? How many degrees of freedom? Wala yung makatagan. So actually na daw. Ha? Come again?
5, sir.
Very good, yeah. So we say degrees of freedom, katong movement niya. Maka-move siya. May alternative words sa how many access. Kung pangitawon kag how many access, that is also the same as what is the number of or degree of freedom of the robot. So dere, so natay 5 access. So dili siya 6 access, no? So for a 5 access, pwede niya nganlan ang access 1 as the waist. So pwede na for a base, access 1. Then followed by a shoulder, no, the access 2. And followed by the elbow, which is the access 3. Then followed by the wrist, which is the access 4. Then finally, ang kaning kuan niya, wrist lang yapon na part or kaning end effector na part, no? The wrist roll na access. Okay? Okay, so let's proceed. Okay, so the robot controller will continue moving the access until it reaches the home position. So this will be complete. This procedure will continue until all access are in the home position. Oh, so mauna dito niya. Okay, so next is describe the areas of robot manipulator. So ginabalik-balik rin yan. So the manipulator, the arm itself is the part of the robot that actually performs the physical task. So a robot's arms is able to move to various positions because it has joints that allow the robot arm to bend much like a person's arm. The joint are called axes. Okay? So it could be the axis could be a straight line or rotational. So kung katong ga-advance na sa katong robotic na may gitawag dito na linear, no? Linear na movement. Katong pong ordinary na movement which is not linear. Okay? So classes of axes. Okay, so these axes are divided into 2 classes. The body axis and the rest axis. Okay? So pag mingon ka body axis, something body axis, so kaning waist, shoulder, elbow. So kaning body, murag general part of the body. Dayon, pag mingon na pagka rest axis, kato na ang end effector nimo. Kung asa imo ang tools na gina-attach. It can be, you can control in terms of view, in terms of pitch, in terms of roll, in terms of your end effector. Okay? So, ano yang sa in terms of the classes of axis. So, in terms of positioning, sa katong iyahang kuan, sa iyang joints, so, kuan, it's more of the body access joints. But iyang final na finale siguro niya na access, it's more of the end effector na. Kung gusto niya i-pick and place ba niya or i-grab niya ang certain object. Describe the 3 types of jog applications. So, something jog. So 3 reasons to jog a robot. Jogging means to move the robot arm manually under power. So, dili siya under program. Siya gi-program. So, bali, maning jogging is also known as manual movement. So, kina-manual movement na ni mo yung mga robot. So, term man is jogging. Jogging is done to position the robot arm. So, ang mismong programming device, man yung ginagamit. So, there are 3 reasons to jog the robot. So, siguro mapay pag-start up. Then another, the next reason is teaching. And lastly is shutdown. Before mo siya shut down, gina-manual jog na mo siya. So, it's home position mo ka. So for the startup, before the robot is put into operation, the arm should be jogged to a certain position. This start position makes sure that the robot is free to move and will not hit any obstacle. Teaching is a necessary step in the programming of the robot. This involves jogging the robot into a desired position to record it in its memory. So sa katong robot DK na to na simulation, tawag ato is mag-create og targets. Target 1, target 2, target 3. Para ginahanap na sila similarity sa teaching or jogging. Okay, so describe the function of a robot teach pendant. So the teach pendant is the programming device as well. No? The teach pendant is a handheld control device that is connected to the robot by an electrical cable. This device is used to remotely jog the robot. Teach pendants can also be used to teach or program the robot. Okay, so hopefully kung na-solve na namo itong issues na battery na problem, hopefully magamit na ito sa Mitsubishi Festo na robot, articulated arm. So teach pendants are typically comprised of the following components. Of course, display screen, emergency stop button, and the keypad. Okay? Lisod po kayo mag-program ka na wala kayo display screen. Then of course, kung sayop ang imong target na pag-teach, mulamba pa sa kalit, at least you can perform the emergency stop button. And of course, ito ang keypads, the hard keys. Tawag ni hard keys. Kaning sa taas, the soft keys or the shortcut mga function keys. F1, F2, F3. So, these are some of the most common functions, no? Sa kaning using the teach pendant or the programming device, jogging, teaching points, move to a teach point, test inputs and outputs, then running. So next is describe the functions of the 2 types of end effector. Okay, ay nag-chat, bantay, 5 sir. Okay, wala na mag-late ang pagbasa. Okay, so summoning end effector. So there are two types of end effector. So kailangan matawag is an end effector device that is attached to sa the end of your coin or the tip of your robot. So end of arm, EOA. Tooling do not grasp an object. So kaning EOA, so pwede siya for for cutting baka or welding, drilling, and so on and so forth. Tooling. So pwede tool ang imong device. Then kung katong naka-dumdum sa robot flange, kaning connecting. Then pag-connect nila sa tool o ang katong robot is katong robot flange as a second. Okay. So in terms of gripper, so napo tayo two types of gripper, no? Nagitawag na 2-point curvilinear o 2-point parallel. So kani guys, sa kitag-an niya ni what is this? Is this a 2-point curvilinear or 2-point parallel? So kani unsay makatag-anan ni? Is this a 2-point curvilinear or 2-point parallel? So actually, one ay pinaka-common na end effector kay gripper kay simple lang. Mura siya mubuka dahil close kanang movement. So nga na curvilinear man because pag kaning imuhang mismong butan to kung asa tong tip niya kaning maka-hold bitaw siya is dili man siya always parallel with each other. Kaning duha is not always parallel with each other. That's why it's a 2-point curvilinear. Na mag-create mo siya curve or circular ang yan. However, pag i-improve na yung design, mara na ginani. So kani siya, pag move niya, kaning mismong imuhang sa metaw gani, kaning tip niya na part is always parallel. Okay? So, kamo na lang tanaw sa video, naaman sa video dito sa kuan sa YouTube na to. Na dito, gipadagan niya. So, always parallel kining duwa. Okay, so that's the difference between kuan curvilinear and parallel. Okay, so we go now to application development. So, ang kaning industrial robot na to, example na kasagaran is CNC machine loading, robot, application, then conveyor operation, okay. Magaling robot works cell envelope. Okay, so 3 classification of robot applications. So, nabalik-balik yung meron. Don't you worry na mabalik-balik siya, at least familiar niyo. So, sa may pinaka-common. These are the material handling, assembly, and finishing in terms of robot operations classification. We're going to generalize the robot application into 3. It's either material handling, assembly, and finishing. So there are 3 primary classifications of material handling in robot applications. So the material transfer or machine tending. So kanang barang mura siya gabantay, machine tending. So example ito katong CNC. Gabantay ra siya dito sa mga ng CNC. There will be a trigger sa iyang system. Turing system. Ito ba yung kuwaon ang final na output sa mga machining. Then, third one is palletizing. Ano yung siya pick and place. But it is within the pallets. Kung dagko imong pallets, ako po ang robot na pick and place. So, kani example, material transfer. Ina-transfer na from one conveyor to another conveyor. Okay. Dayon another is machine tending, matong magbantay ra siya. So, human na process ang example sa CNC. So, pwede na dahil niya or katong kung estudyante dati na siya ang trabaho is na i-involve ng injection molding machine. Plastic ba na molding, kung sa bakan siya na kuan na material ang ganito. So na pa na process. Pwede po siya pag mahuman, ma-mold na, hindi niya kuha ng product. Dayon palletizing, so just like atong sa Coke na video sa YouTube, gina pick and place lang niya. Kani is atong pallet is a wooden pallet. Then of course ang box ginabutang niya. Taman sa mapuno, then it will proceed to the next assembly or next na stage sa packaging. Siguro warehousing, ipadong sa warehouse for housekeeping. In terms of assembly, so kani murag electro-pneumatic siguro na type of robot, dili siya servo type. So pwede siya mag-fit, no? One of the assembly na style is fitting, gina-fit lang niya. Then ang uban, fastening. Attach lang yun. Kung naamang ganun siya nuts, bolts, mga na gina-fasten na niya. Dayon, another type of assembly na activities, gluing, gina-glue lang niya. Okay. In terms of finishing, so some of the examples are may painting, trimming and debarring, and yeah, basta it's more of finished product na siya, finishing processes. Okay, so na may pangutana which is we go now to application development. But na human na ba na ako ni? Okay. Yan na pa de. So how robots are applied to CNC loading. So balik-balik gyapon ni example, no. Gali lang gina-specify niya diri na at least napakita na, let's say you have the CNC output, no. In this example, it's more of a milling, no? Yan ang ginapakita. Ayan, na kay vice, no? Yan, ginabutang yung mga kuhan. Yung mga tawagan niyo. Yes, naipangutana. Wala. Sige. Let's proceed. Okay, so pwede na within the CNC ni muna kuhan. Sometimes the robot itself will butang na mong material din to be processed via this machine vice. Okay, so advantage of using a robot to a CNC machine loading, no? So to make a part, nakahimo na part sa imo ang machine, dapat imo daw ipagian man ni mag-late. So this time the operator loads the part into the vise and clamps it and presses the start button in the machine. The CNC machine then performs a series of operations to create that part, no? When the operation is complete, the operator unclamps the vise and removes the part. Then cycle can be repeated. So the CNC machine is a good application for robot loading because the task is repetitive and sometimes it's boring. Mas okay pa ang manual na lathe machine as compared to the CNC na lathe machine. Say computer CNC, it's a computerized computer numerical controller. So which means ang input nimo is a CAD wala na kay drawing daan, i-load na lang nimo sa CNC, automatic na gina-process. So, if it's a late machine, so buo na dahil ang imuhang part ng itong mismong imuhang gina-machine, workpiece. So, it's a little bit boring. Unlike sa katong ikaw maghimo sa machining, so if it's an operator, okay ra. Pero kung ang imong trabaho as an operator kay pareha sa trabaho nilang Sir Dexter dito sa Taiwan, nag-loading ra sila din, nagbantay ra sila sa CNC. Murag katulgon no, permin din Sir Dexter. So, mga na, no? So, pwede dahil po na pulihan na lang nato og industrial robot. Kay boring naman ang trabaho. Okay, so na may pangutana. So, let's proceed. So, pwede inani ang iyang detailed na example sa kaning using a robot for a CNC na machine na production. So, na kay different section, na kay conveyor, siguro dari ang input sa imong mga workpiece. Of course, there is a sensor. Then you have the CNC machine. Then of course, i-emphasize lang niya na the robot controller, na say wiring pa dog sa yung robot. Okay? So, mga may diagram. So, metabuhan step 1, the robot picks up the part and places it into the vise. No? Kaning vise na to, ano pa ni? It's either hydraulic or electromechanical. No? So, automatic na. Kuan. Lisod pag kayo kung ang robot ipatuyok pa nimo sa vise para mabutang ang imo ang workpiece. Kasi automatic na siya sa electromechanical na control. Butang niya, so butang na sa robot, pick na niya. So magpaabot na siya, no? Paabot na siya na ma-process sa imong CNC machine. After na, umana na, pwede na niya kwaon. Pwede niya kwaon. Butang na niya sa mga sa tong parts na or butang niya na to parts bin. Itong mga sa mga final na mga workpiece na sa ginana na example. Okay? Hindi? Napa ba ni? Okay, marag mga sining last na to na topic. No? Hindi na human, baka na ko ni. Marag nakalimot po ko. Sige, padayon ta. Mira ko gumanan na. Okay, so let's define the work envelope of a robot. Okay? So, manotice ninyo, the servo ang gigamit ani, check tag-ani niyo. Is it 180 degrees servo, just like ang typical na micro servo na palit nimo para sa sa imuhang Arduino. No? I don't know kinsay nakatry niyo to. I-attach na to ato ang ultrasonic sensor. Will it be kato na type na servo, 180 degrees? Pila ka ni ka degrees na na servo? Based on the work envelope na drawing. Kinsay makatagaan. Sa kanin na servo, guys. Is it 360? 360 ba na siya? Dili. Hello, wala naman siguro question. Napa 59 kung nakabook, wala may maningog.
240, sir.
320.
Pila? Come again, pila? Pila ka degrees ang ato ang servo na gigamit? AC servo siguro ni.
320, sir.
Okay, so wala 220 na servo. It's 270. So I don't know, siguro na customize, but typically paano siya 180 degrees the servo, then 270 degrees dahil 360. Napoy 90 degrees the servo. But ang pinaka-common sa kanina case, it's 270 degrees. Though dili kay accurate ang pagka-drawing, but more or less this is a 270 degrees or more siguro no na servo market. So since 270 raman siya, dili siya katuyok yun, no? 360, 270 ra. Let's assume that value. Okay? Okay, so Maura na yung work envelope. So, okay, so let's now consider a double joint robot. So may tabo sa itong work envelope. So say pasabot ng double joint na robot. So pwede siya mabaliktad, no? Pwede siya mabaliktad sa pigkas. So some robots are designed to flip over to reach the area directly behind. To do this, either axis 2 or axis 3 of the robot must have larger range of motion than the other axis. So this is called a double jointed design. So working namin, pakuha siya sa iyang likod. So if that is the case, now, what are the advantages if it is a double jointed design? So larger work cell area, tight space navigation, kaya niya, quicker work envelope travel time. So, murag inani, no? Oh, naninana man siya. Murag di ko na siya, ni baliktad, no? Baliktad. Wala lang nato napakita dere. So, tanaw ninyo dito sa YouTube channel. Ang iyang working envelope dire ra. Pero once na siya dire, pwede siya mabaliktad. Pareha ni example dire na mag-flip siya. Flip siya on the other side. So that's why makaya na niyang access ang 360. Ano siya, it's seemingly murag 360 ang work envelope sa robot arm using a double jointed design. Okay? So kani example, pwede siya matalikod. Pwede siya matalikod. So dili lang na siya simulation. Ay aning video. So marami na ng idea, pwede siya matalikod. So quicker work envelope travel time. Of course, kung makatalikod ang robot din, much better. Okay, so that concludes our discussion karon. Na may pangutanan. Okay, na may pangutanan guys. Okay, ako na nang stop ang recording. Stop recording. So before na ko stop ang recording, na may question. See you on Wednesday, no? Wednesday and Thursday. Yeah, Thursday ano ba Wednesday for our laboratory. Okay? So kung wala may pangutana, mag-selfie sa siguro to our groupie. Sige daw, Bi. Kita daw mo sa inyo ang podya. Sa inyo ang face. Okay, so 1, tulo man din ikakuha na ka-page. So, katulo ko mag-screenshot. 1, 2, 3. Okay, so first page. Page ako. Save. Save. Next page, smile lang yapon. 1, 2, 3. Magagamay pa na ako nakita. Red screen. Sige na lang. Uy, ay nagklase ra sa kuwan. Sa takas. Save as number 2. Then lastly, page 3. Lagi man na naong nagawas dito sa page 3. Wala na sa okay, so stop recording na to. Wala mo ilahin pangutana. I hope na dili kayo putol-putol na itong kuwan. But anyway, you can always go back sa YouTube channel na video. Okay, so stop recording.